This is Geometry, Unit 4, Day 11 worksheet. So what we're going to look at here is we're going to make a plan for how we do our proof, and then we're going to go ahead and fill in our proof. So AK, alright, notice how our two triangles overlap. So what I would suggest to do is to redraw the two triangles, AKB, CJ and B, and you can notice here AKB and CJB, those are the two big triangles. They're overlapping. So AK is supposed to be congruent with CJ. Angle BJC is congruent to angle BKA. Angle A is supposed to be congruent to angle C. So that's all of our information. And if you look closely, it doesn't look like we're going to have to come up with any additional information. They've done all the work for us. That was all the given. So now I know that triangle ABK is congruent to triangle CBJ. And the reason? What is one of our 5 reasons? Remember, our 5 reasons are SSS, SAS for side, angle, angle, side, angle, and then that right triangle, hypotenuse, leg. So clearly it's not side, side. It's not even side, angle, side, because we don't have 2 sets of sides. It's going to be angle, side, angle. Notice that we're taking the 2 A's with the S that's in between those A's. This next option here, we have W, X and Z, V and U. So we know that VW is supposed to be congruent with UW. Angle X is congruent to angle Z. Now what's a third bit of information that we know for sure? This is a tricky one. We don't usually see it like this. The angle W, look here in the original picture, angle W is the same angle in both triangles. It's called the reflexive property. So we'll start out with our given information. And then we'll be able to talk about how angle VWX is congruent to angle UWZ, and that's reflexive POC. Then of course our last statement is what we're trying to prove. And how would we prove the triangle is congruent? We have 2 A's and the S on the outside. Angle, angle, side. Again, our triangles are overlapping. That is triangle LKM and that's triangle NMK. So we know from our given information that angle NKM is going to be congruent with angle LMK. And then angle L is congruent to angle N. Now, what's another piece of information? Remember, we always need three parts to be able to make it congruent. So we talked about them earlier: side, 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 angle, angle, side, angle, or RHL. If we have a right triangle, the hypotenuse and leg could be enough. Well, we don't have right triangles here. We have two A's. What's the other part that we definitely know? It's going to be a side. If you look up here in the original picture, it might be more obvious, or just look at the labeling down here. We have a reflexive side that both triangles are using. So that's our plan for how we're going to prove these triangles congruent. We start with our given. Then we have our reflexive property. Km is congruent to Mk. It's going in opposite directions. And that's the reflexive POC. And then our last step is to prove the triangle's congruent using one of our 5 ways. What method are we going to use? 2 A's and an S. On the back side, we're going to take our picture. We have Y down here, and the missing one must be Z, and that's up there. Can't quite see it because it's in the fold. We know that X is the midpoint of both segments. So both of these segments have X as the midpoint. Alright, so that gives us 2 S's. Is there a third S or a third side that we know are definitely congruent? Or do we know of any parallel sides? Do we know of any vertical angles? What's the other option that we definitely know about? When you make that big X, you make vertical angles here in the middle. So what we've learned in the past are vertical angles are congruent. If 2 angles are vertical, then they are congruent. We wouldn't redraw these because the triangles are not overlapping with each other. So X is the midpoint of VY and WZ. That was our given information. So that was midpoint. Now midpoint doesn't actually say things are congruent, just as it is. So we now have to go in here and say that Vx is congruent to Yx and that Wx is congruent to Zx. If midpoint, then congruent segments. The midpoint tells you that you have 2 segments that are congruent. Okay, so here we have our 2 S's. What else are we going to be able to say? We talked about angle VXW being congruent to angle YXZ. You have to use 3 letters because of how X can go in any direction. If vertical angles, which yes, we have vertical angles, it's shown that in the picture, then congruent angles. So then we end with what we're trying to prove. And what's the method that we're going to use to prove them congruent? It has to be one of our 5 ways. We got 2 sides and the angle in between it. 2 S's with the angle in between it. Last one. AD is parallel to CE. Now, we've talked about what does it mean to be parallel. What are we actually supposed to think about? You should think about one of your 4 different types of angles. Alternate interior, consecutive interior, alternate exterior, or corresponding. Which angles are we going to talk about here? It makes a zigzag. Comes up, across the transversal, and back up. So A and E are going to be the same measurement. Now you could talk about the parallel line, the different transversal and the parallel line. You could talk about those. We also know that BD is congruent to BC. So we're going to start out with our parallel segments and our congruent segments. That was from our given. Then because we had parallel segments, we know that angle A is congruent to angle E. If parallel lines, that's what we have, it said earlier, then alternate interior angles are congruent. Now, this was actually a choice that we had to make. We could have talked about that, or we could have talked about the vertical angles. That was up to you. This is what I decided to do, was to talk about the other set of alternate interior angles. They also want us to talk about D and C. Angle D and angle C, if parallel lines, then alternate interior angles are congruent. Now we can finish with what we're trying to prove. And how are we going to do that? One of our 5 ways proves triangles congruent. Angle, angle, side. We got 2 angles in the side non-interior, or we have 2 angles in the non-adjacent side. Two angles and the non-included side. That's why the S is on the outside.